As most of you already know, I'm currently building my own record embossing lathe. The goal is to create a 10-inch record cutting lathe in a transportable box. Please check out my other episodes to follow along my process. If you like my content, feel free to support me via PayPal.me. To cover the underlying structural components, I will add some acrylic cladding in the end. This cladding will not only protect the inner parts of the machine, but also visually clean up the design for better usability. Furthermore, the cladding will house the control panels. To raise the cladding on one side, I had to install 3 more 3D printed support blocks, as you see here. In between my work on the cladding design, I was testing the basic movement of the stepper motors. First, I tested the back and forth movement of the feed unit for the cutter head. I also made the first test cut just to figure out if the feed unit motor was strong enough, which seems to be working just fine. Next, I realized that I had to swap the motor for the turntable drive. The old one was too loud, produces too much resonance and did not have enough torque. I found a good replacement that should be just fine for the first prototype. For stepper control, I used this driver setup from a guy I share my studio with. I will talk more about this in a later episode. To get the correct speed for the turntable drive motor, I used a strobe light and a disc with a corresponding pattern for calibration. To make the power cable's placement safer, I installed a housing where the wires are routed inside. Again, I'm using cable ties to fasten loose cables in place. The cable for the end stop is also installed along the substructure. The same goes for the twisted audio cable. On one end, this cable will be attached to the lever arm and therefore has to be moved along the distance the feed unit travels. The embossing head is connected using tiny sockets from the automotive industry. They will make it easier in the future to swap out embossing heads. I'm using a 12-volt amp that has enough power to support my exciter speakers, with plenty of headroom left. First, I wire the left and right channels to the amp, and then the power supply. At this point, I also do a first test run with a laptop and some basic audio software, with good results. To get the correct curves for the corners of the suitcase, I use a contour gauge. That helps me visualize the right geometry later in the 3D construction software. For the first prototype, I use cardboard. It is easier to laser cut and trim to size. After the center cover is ready, I create the right side panel cover. The panel will later be made out of red acrylic glass and bent into shape using a hot wire. The first try is not perfect, but it shows me where I need to correct some details. To get all the electronics right, I'm working together with this guy from Hey Toto Company. He builds coffee robots from scratch, so he will help me design some PCB boards for my machine. Check out his channel, he's making some of the best coffee robots you have ever seen. For the correct placement of the switches and knobs, I created a prototype out of cardboard. It will look something like this in the end. Underneath the acrylic layer is the first PCB board that houses the switches. A stepper control PCB board will be installed underneath. It was a good idea to create such a prototype in full scale, because I realized that I have to move the buttons closer together to shrink the PCB board to a minimum. I hope you enjoyed watching this episode. See you next time.